Now, I tend to improperly call it a house a lot, but it is technically the radical symbol. Symbol. Good gravy. Okay, and then if they put a number on the outside, what is this called? The index. Okay, and so if they have an x underneath, how can I rewrite it? And maybe I have an x squared underneath. How can I rewrite it from a radical expression to a rational expression, meaning I'm going to go with exponents? I'm going to have some exponents. It's x to the what power? Is it 2 over 3 or 3 over 2? Which? Oh. It is. Obviously, we are still confused on that. It's 2 over 3. The index goes in the denominator. The index goes in the denominator. So let's do another one. We'll do 4 raised to the y raised to the 6. So what should I rewrite that as? Well, I have a y, so it can't be x to the nothing. Yeah, 6 over 4. And then if you want to reduce that fraction, which is something apparently my third period class hates doing, 6 over 4 reduces to 3 over 2. I like reducing fractions. It's not a problem. Okay, so we were working, oh my gosh, have I talked to you about how I hate today?
Scholars Bowl and anime to the gym for club pictures. Scholars Bowl and anime.
Go.
Thank
If
you.
you're one of those, go. You're not either of those. This is my least favorite day of the school year. If I was old, no cracks about me being old, because I'm not old. If I was old, I would take off this day every year, because I do not like being interrupted 5,000 times. It is so annoying. It is okay, though.
I didn't go to like half the pictures.
Okay, I got it. I got my act together. Okay, yesterday we were talking about how to break down something like 45. If I wanted to get all its prime factors, what would I break 45 down into? 3 times 3 times 5. And what is my understood index on this example?
2.
An understood 2. So then what would my final answer end up being?
It'd be the 3 would be on the outside because and then the 5 would be inside.
Okay, so I had a pair of 3s. So a 3 is to come out. And then, okay, so a 3 and then the square root times 5. So 3 radical 5 works, or specifically because the index is 2, 3 square root 5. Are there any questions about this method?
So that's right?
That's right. This is always going to work. Always going to work. But I understand that, like, I'm going to call Rex out. I know Rex. Rex does not like the circling technique or listing out all the prime factors. That takes way too long, especially with a really big number. That's too time consuming. There has to be a better way, he surely thought. And there is an easier way. But this way always works, and if you're not good at your multiplication skills, then breaking it down all the way to prime factors will always work out for you. Yes.
Okay, so say, because in the problem I'm doing right now, it has where like 2 numbers can come out, like 5 and a 2. How would you write that?
Okay, so and then I saw there was another problem like that too. Let me get out the sheet. It's behind me. I wanted to do
like number 4.
Number 4. She asked me about number 4. Where is it? There it is. You got square root of 300.
Yeah.
And you broke it down into what times what?
3 times 5 times 5 times 2 times 2.
Okay, if they both get to come out, because you're saying both the 5 and the 2's get to come out, so you have a 5 on the outside and a 2 on the outside and a square root of 3. We do normal math skills, so it's 10 square root of 3.
Okay, so you just roll 8.
Yes, and then I noticed on number 8, so this was, she asked me about number 4, this is 4. On number 8, I noticed there was a 4 on the outside. We're going to leave him on the outside, and anyone you bring out, let's say you brought out a 3, I have no idea. Anyone you bring out, you'll multiply the 4 by, so 4 times whatever it is you bring out.
Would you have to have
No, I'm just saying whatever gets to come out gets to be multiplied by 4. The 4 gets to stay. He doesn't go anywhere. So if you bring anyone out, you get multiplied by 4. So let's do number 8, since there's a little confusion on that. 192 breaks down into what? Does anyone know? 192. 96 times 2 is 192. And then can we break down 96 any? 6 and 16 is 96. So that's really 2 times 3 times, and then 16 is 2 times 2 times 2 times 2 times 2. Good gravy. So if I did my circle buddies, I got one pair of 2s, another pair of 2s, 3 pairs of 2s. So 3 sets of 2 are coming out.
So that'd be 2.
And it would be 2 cubed. So I have a 4 already on the outside. Then I have a 2 cubed coming out. And the poor 3 is left at home by himself. So I didn't go over this. I guess I just thought y'all would assume it's normal skills, because it is. You know 2 cubed is 8. You know 4 times 8 is 32. So my final answer is 32 square root of 3. It's normal math. Normal math all the way out. Okay, are there any more questions about yesterday before I show you my trick? Okay, again, I will reiterate this one last time. If Emma likes doing this all the way into prime factored form, and then she likes circling however many, like the index is 2, so she needs 2 of each. The index is 4, so she needs 4 of each. That is always going to work. She can always do that. However, most math people probably don't do that. Like a mathematician is not going to do what you and I are doing, because they know their perfect squares. So what is 1 squared?
1.
Okay, 2 squared. 2 squared? Okay, 3 squared. 4 squared. 5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. If you don't know the first 10 at least, then we're in trouble. In fact, we should probably know the first 20.
We had to learn that last.
You should know the first
I learned
20.
it, but I don't.
I remember 13 is like 169 and 14 is 196.
That is true. Those are very useful things to recall. Now, I'm not going to necessarily test you on this, but these perfect squares can be useful. For instance, we were just working number 4, and it said square root of 300. There is an easier way than what we were doing. So what I'm going to do instead today is surely I'm going to think through. There is some perfect square that will go into 300. And I would love for it to be the biggest perfect square I can think of that goes evenly into 300.
At this time, can I have International Thespian Honor Society to the gym to take club pictures? International Thespian Honor Society. Thank you.
Oh, Actor Honor Society. Okay. What perfect square is going to go nicely into 300?
150 times 2. Wait, no, sorry.
Which one? I've listed a whole list of perfect squares.
100.
100 times 3 is 300. 100 is a perfect square. If you can find a perfect square, then automatically the answer is going to be 10 square roots of 3. If you can find a perfect square multiple, automatically he's going to come out, and it's going to end up being 10 square roots of 3. Meaning, and if you were looking at me like, this is how I'm going to explain it today. It's a different way than I explained it yesterday. So right now, 103 are married. But sadly enough, they're going to get a divorce. So they live in 2 separate houses. They live in 2 separate houses. Do you know what the square root of 100 is? 10. Do you know what the square root of 3 is off the top of your head? No. So that's why we're going to leave him under the radical. So we can work through almost all the problems we were doing yesterday, because most of them were square root problems. And this would be a much easier, faster way. For instance, we had just talked about number 8. It was 4 square roots of 192. And I believe, was it you? What did you tell me multiply to get 192? I need a number that's a really big perfect square.
13.
36 times what?
Just
13 is not a perfect square. A perfect square number, like 1, 4, 9, 16, 25.
4.
We would love a big one.
8.
That's not a perfect square. 1, 4, 9, 16, 25. Like 1 squared, 4, 2 squared, 3 squared. One of these is a perfect square number. I want one of these.
49 squared. 400 squared.
49 goes into 192. I would love for one of these numbers. Times something. 64 times what is 192?
16 goes into it.
64 times 3 is 192? Okay, so she's right, 16 goes into it, but we wanted the biggest perfect square we could come up with. Oh, lo and behold, 64 is a perfect square. If you know your multiplication tables, if you can come up with a perfect square, then once they get a divorce, so 4 square root of 64, square root of 3, I have 4 times 8 times square root of 3. I get 32 square roots of 3. And this is so much faster. And honestly, don't get your feelings hurt now. This shows you really understand your multiplication tables more than those of us who are breaking it down into prime factored form and happen to circle.
Can you break that in prime factor form? I didn't see it.
Yes, we just done that one. I just done that exact one. So, it tends to be, I'm not even gonna lie, it tends to be either 64, my goal is 64 normally. 100 is kind of obvious. My goal is 64. If I'm not sure about a number, does 64 and go into it evenly. If 64 does, and I'm like, man, I had my hopes set too high, I wonder if 36 does. 16 tends to come up in a lot of math problems, don't know why, it does. It's okay if you don't come up with the biggest perfect square. Let's say we had done this the way that, who had said 16? Emma, did you say 16? You said 16. 16 times what was 192? Let's show what would happen if we did it Natalia's way. 16 times what? 16 times 12. Okay, if we did 16 times 12 and we gave them a divorce and we said 4 square root of 16 square root of 12, we would have had 4 times 4 and then square root of 12, which is 16 square root of 12. There's nothing wrong with this except Natalia's not done because the square root of 12 is not as low as she can go. Can't you break 12 up into a perfect square? Isn't it what times what makes 12? And one of those numbers needs to be a perfect square. What times what is 12? Just start 6 times 2 is either of those a perfect square. So it has to be 4 and 3 because 4 is a perfect square. Hey, lo and behold, there's my perfect square. So if I can come up with one of them as a perfect square, when I give them a divorce, I'll have 16 square roots of 4 square roots of 3. I know the square root of 4, it's 2. I get 32 square roots of 3. Every way I've worked this problem, whether I went with the big old 64 that Emma came up with, English, or if I go with the 16 that Natalia came up with, which required a few more steps, or even if I do the prime factored form, I still end up getting 32 square roots of 3. But this is more impressive because this really shows you have some great multiplication skills. So let's look at another one on your sheet. This is only going to work with the perfect squares. Obviously with cube root of 16, like number 11, just because you know 16 is 4 times 4, so it's perfect square, this only works for when the index is 2. It's only going to work for 2, which is why the prime factor form is probably the way to go. Number 5, for instance, is easy. Look at 5. You sure?
I don't know.
Okay. So obviously number 2, let's just start at the beginning. And I'm just going to start spouting things off, and either you're with me or you're going to have to do it the long way.
At this time, can I have NHS and to the gym for club pictures? NHS. Thank you.
For instance, let's look at number 2. Number 2 says 150. What is a nice perfect square that probably goes into 150 prettily?
10.
Is 10 a perfect square?
I don't understand the
Understand
perfect square.
Right.
A perfect square is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, which are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And the reason we're looking for these, one of these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 100, is because they would be the easiest, because you know what the square root of 100 is. That's 10. You know what the square root of 81 is. That's 9. This is why we're looking for these numbers, because you already know these answers. Square root of 49, oh, that's 7. Square root of 36, that's 6. Square root of 25, That's 5. This is why we're looking for these numbers, because those are problems you already know the answer to. So it helps you out in the long run. Yes, agreed.
So, like, how does it?
How does it help in the long
I
run?
don't understand how you're plugging it
Okay, so our problem was, and I was trying to do number 2, it said 150. I'm trying to pick a number from this list, 1, 4, 9, 16, 25, one of these numbers that divides nicely into 150. Aubrey's right, 25 goes nicely into 150. 25 times what is 150?
6.
Okay. Yes, dear. Is 50 a perfect square? Okay. So we're trying to come up with one of them being a perfect square. Okay, so we got 25 and 6. If they get a divorce, we'll have square root of 25, square root of 6. And so my answer is 5 square root of 6. I'm not having to do near the amount of work I was having to do yesterday. I need a perfect square. A perfect square times some other number. I need a perfect square. Okay, so I did number 2. We got 5 square roots of 6. We've already done number 4. We got 10 square roots of 3. I want to do number 5. Which is 360. And no one help her. Give her some time. Let her think about what it is. Either of the hers that are mad at it. Either one. I need a perfect square that multiplies to get me 360. What is a nice, pretty, perfect square that goes nicely into 360? That's not a perfect square. He's wrong. That's why I'm pushing him. What times what is 360?
I don't know off the top of my head.
Oh my gosh, yes you do. What times what is 360? Just tell me some numbers. What is?
What's 1/6?
What times what is? I'm talking to Natalia only. I only need Natalia at this moment. What times what is 360?
180 times 2.
180 times 2. Is 180 a perfect square? Okay, so pick a different number. What times what is 360?
36 times 10.
36 times 10. Is 36 a perfect square?
Yeah.
Okay, 36 times 10. Then they get a divorce. So I got square root of 36, square root of 10. Okay, so I end up, square root of 36 is 6. I've got, in square root of 10, square root of 10 can't go any further because it's just 2 and 5. You're done. That's it.
That is 10 times each and bulk factoring it out.
That's what I'm saying. That's why I don't understand why you're mad at
I'm
it.
not mad. It just took me a second to get it.
Okay.
Over again.
Okay. Let's do another one. Let's do another one.
Yeah.
Oh my gosh, man.
Can we do one that we do them all like this? Like,
Oh, an index, a different index. It's only this perfect square thing, it's only gonna work with the index of 2.
Oh my god.
But I happen to know, I'm not trying to like,
is there a way to do a cube one?
okay, I'm not trying to mind blow today, but yes,
You
yes.
can explain.
I will explain it to you one-on-one later, or else the mind's blown, stuff all over the floor, but yes, yes. Okay, so let's see, I see another one.
I don't like the one where it has like
We do 3. The index outside.
We can do 3. I like 3, let's do 3. 3 is square root of 245.
Wait.
No one help Ty.
What if it's like number 3?
The index is 3.
No, I like the long way better.
What if it's number 21? Oh.
I can still do it. I'll do that one next. No one help Ty. Think of things that multiply to 245, Ty. Get your calculator out, start typing. What's going to multiply to get you to 245? Nobody help her.
5.
5 times, it's 5 a perfect square.
Wait. No.
Okay, but 5 times what was 245? We're starting somewhere and that works.
5.
Times what? You did 245 divided by 5, and what was your remainder?
Oh my God, 49.
49. So she said 49 and 5. Is that good? Should we go with those?
Yeah.
Why?
Because that's the square.
Okay, so 49 and 5. So what is my final answer, Ty? Don't tell her.
Man, I got it now.
245.
Give them a divorce, Ty.
Oh, 49 squared and 5 squared.
Okay, now what is the square root of 49? I don't know why she said it like that. What is the square root of 49?
7.
So what is my final answer?
5 squared.
7 square roots of 5. 7 square roots of 5. But yes, close enough. Close enough. Yes. This is much easier. Now Katie is very. Thank God. Flip to the back.
With the long way. Get it.
You crazy. Go to 21 on the back. 21 on the back. 21, you said? 28? You want 21? Okay. Okay, Katie asked. Okay, focus. I'm almost about to release you and let you go back to your life. I might even let go of adding and subtracting today even. I might let it go. Okay, let's go back to 20. Let's look at 21. So Katie's asking about harder ones that start involving x's and y's and stuff like that. So what I do, Katie, 21 says square root of 180 x to the third. Let's face it. You already know what the x thing is going to be. What should I get with the x piece?
I don't know.
I don't like the variable one.
If there are 3 of them, what's the index? The index is 2. So how many do I need to come out?
2.
Okay, so who's left in? Okay, so my answer is going to be x, because when x comes out, square root of x, because he's left at home. So I know it's going to be x square root of x with the x part. I'm just trying to figure out what to do with the 180. So 180 is what times what? 60 times 3 is correct, but neither of those is a perfect square. I need a perfect square. 9 times what?
2. No.
20. But if we do 9 times 20, is that the biggest we could go? That's my question. Okay.
That's not even a square.
Okay. I like Aubrey's suggestion with 9 times 20, but 20 ends up breaking down to 4 and 5. 4 is a perfect square, so there is a bigger one. 36 times what? 36 times 5. You ask your calculator. If you still wanted to do that circle thing, you could, Katie, if you're still mad at the exponents. Okay, so 36 ends up being 6, so my final answer is 6x square root of 5x. You understood the 6. You understand the 5. You understand the x's. Put it all together. 6x square root of 5x. 6x square root of 5x. You understood the x's because there were 3 of them. We needed 2. 1 comes out. 1 stays home.
So you just ignore
Hey,
36.
I do with just the exponents. I mean, just the numbers and then just the variables. 2 separate worlds.
Ignore 36.
I'm ready for this test.
I broke it down into square root of 36, square root of 5, and that's 6 square root of 5. That's where I got the 6 from. Okay. I think you're going to be okay. You're allowed to work together on this. I will let go of adding and subtracting until tomorrow as long as you get a majority of these done. I want it done and in my hands tomorrow and a smile on your face. You're happy with it done. I'm going to stop now. I'm not going to do the other thing today. I'm going to stop. The check.